Let's look at one more example involving the principal unit normal vector. So for example, let's find n of t and n of 1 for the curve represented by the vector valued function 3ti plus 2t squared j. So we're going to start by finding our unit tangent vector. So I've got to take the derivative of this function. I'll get 3i plus 4tj. And I'm also going to need the magnitude of this vector. It would be the square root of 9 plus 16t squared. And now that I have those, I can find my vector t. So the unit tangent vector t, remember it's r prime over the magnitude of r prime. So t will be 1 over the square root of 9 plus 16t squared times the vector 3i plus 4tj. And I am going to go ahead and distribute this out. So let's go ahead. This would be 3 over the square root of 9 plus 16t squared I. This would be plus 4t over 9 plus 16t squared j. And then I'm going to rewrite these terms here. So this will be 3 9 plus 16t squared to the negative 1/2 I plus 4t 9 plus 16t squared to the negative 1/2 j. And this is my vector t. And the reason why I rewrote those terms is because now I need the derivative of this vector t to find my principal unit normal vector. So we're going to take the derivative now, t prime. So for the I component, you're going to use the chain rule. So you'll get a negative 3/2. When you bring the power down, 9 plus 16t squared, subtract 1, so minus 3/2. And then you multiply by the derivative of the inside, which is 32t. That's the I part. And then for j, we're going to have to use the product rule here. So it'll be 4 times 9 plus 16t squared to the negative 1/2 plus, and then it'll be 4t. And the derivative would be negative 1/2 9 plus 16t squared to the negative 3/2 times the derivative of the inside, which was 32t. And this is the j component, so there should be a j there. So now let's do some simplifying on this stuff we have here. So let's see here, the 2 cancels, this would be 16. So we're going to get a negative 48t over 9 plus 16t squared to the 3/2 I. And then over here we're going to have 4 over the square root of 9 minus we'll just leave it as a 1/2 power, I guess. So we'll leave it as 9 plus 16t squared to the 1/2 power plus, so here this 2 will cancel, give me a 2 there, times 32, so, but there's a negative, so it'll be a negative 64t squared over 9 plus 16t squared to the 3/2 power, j. So then get a common denominator for the j component. So I'm getting, my common denominator would be this denominator that's over here. So I'm going to multiply the first fraction by 9 plus 16t squared on top and bottom. And now that they have the same denominator, we could go ahead and combine them if you want into one fraction minus 64t squared. And then if you simplify in the numerator, it's gonna, so this is, again, this is t prime, negative 48t over 9 plus 16t squared to the 3/2 I. And then in the j, we're going to be left with plus 36 over 9 plus 16t squared to the 3/2 j. So there's t prime. What we can do is we can factor out some of the stuff that they have in common. If you look, I have multiples of 12 up here, so I can factor out a 12. The denominator's the same. I can factor out 9 plus 16t squared to the 3/2 power, and I'm left with negative 4t I plus 3j. And there's my vector t prime, but remember to find our principal unit normal vector, n. I need to find the magnitude of this. So the magnitude t prime of t will be, well, 12 over the square root. And if I square these, you'll get 16t squared. You'll get 9. And then you square this denominator that's here. So the 1/2 power will go away, and it'll become 9 plus 16t squared cubed. Well, you have the same thing in the numerator and denominator, so it's now just 1 over 9 plus 16t squared squared, or when you take the square root of a square, they're just going to cancel there because the denominator is positive. And here's my magnitude of t prime. So I'm finally ready to write down our principal unit normal vector, n. Remember that it's t prime over the magnitude of t prime. So this will be, here's my magnitude, and then back here was my vector t prime. So if I divide here, the 12s will cancel, and you'll be left with 1 over the square root of 9 plus 16t squared, a negative 4ti, and a 3j. And there's my vector n. So finally, we need to plug in t equals 1 to get our second vector, n of 1. If I plug in 1, I'll get 1 over the square root of 25, negative 4i plus 3j. So we'll get negative 4/5 I plus 3/5 j. And that's the vector n of 1.